All right, so we're on the second part of our discussion of atomism, or our section on atomism. We're really going to get into the meat of the theory now. Before we were itemizing some of the key premises that the atomists uh, uh, draw from or stand on, I guess, base their position on. And that's important because that reveals some of the underlying assumptions, right? Not to say assumptions. Let's say the underlying premises. To say they're assumptions means that they don't have arguments for them, right? But we saw also the arguments that they give for those uh, basic premises. Let's say instead of assumptions. Um, so now the position overall, as we said before, is that everything is atoms in the void. In more detail here, we have it that as we see the cosmos, right, the universe, everything that exists, and all the change in it is explained as resulting from the motion of atoms in the void, right? So atoms are moving in the void, and basically they are sort of conglomerating in places here and there in different ways, and the objects that we observe in the world and the change that we observe among those things is at bottom reducible to atoms moving around and sort of bumping into each other, right? Okay. So that raises the question for the atomists, well, what makes the atoms move in the way that they do, right? We saw that the pluralists had the same question. So if you recall, the pluralists that are like the atomists in that they postulate a plurality of things, many things, whether that is, four elements, as Empedocles had it, or seeds of everything, as Anaxagoras had it, right? Um, they needed to explain how these things get mixed and unmixed, right? And so Empedocles had to postulate love and strife as sort of two forces that explain these motions, and Anaxagoras postulated mind, right? A kind of a sort of universal mind, which for him is the cause of the mixing and the unmixing of the seeds, right? And the separation of things into their separate species, let's say, right? So the atomists have to actually now answer that question. What is it that makes atoms move in the way that they do? So why is it that things change? And they all agreed that the things and events in the world result from collisions of moving atoms, right? But they disagreed on the nature and cause of the motion. They disagreed on why these atoms move in the way that they do. For Democritus, there's no reason why the atoms move in the way they do. That's just what they do, right? So that seems like an unsatisfying answer for these two reasons, right? The first is that it leaves an infinite, irreducible variety of different motions. And secondly, it violates the principle that nothing comes to be from nothing, because it seems that the motions would come to be from nothing, right? Things would just move in the way that they do. So for example, we have it that apples are certain motions of atoms moving together in a certain way, conglomerating in a certain way. And if we were just now to say that atoms move in that way for no reason, they just do that, that would be tantamount to saying that apples just come to be from nothing, right? Epicurus had a different uh, position or hypothesis. He actually tried to explain the motion of atoms. And his explanation was essentially that atoms are falling, right? To put it, atoms are falling through the void with swerves. But we'll talk about the falling first, and we'll talk about the swerves after. Why did he say atoms are falling, right? Well, again, we need to explain the falling, and for Epicurus, for him, by observation, it seems to be that falling is the sort of one motion that just happens naturally without any need for explanation, right? Because if you let something go, it falls, right? And all objects fall, right? Unless something stops it. So with regard to any other kind of motion, if I, leave a stone on the ground, it's just gonna sit there unless something kicks it or pushes it or moves it, right? But if I put a stone in my hand and then drop it, the stone's gonna fall unless something stops it. So falling seems to be a different kind of motion than any other motion, simply because falling happens by itself and only stops when something stops it. Whereas other kinds of motions don't happen unless something moves the thing in that way. Therefore, falling is a natural motion, right? Falling is a motion that doesn't need any specific explanation. It just is a motion that happens. And so for that reason, we're going to conceive of the atoms as falling through the void, right? Everything naturally seems to be falling. And so since everything is atoms, atoms are falling, right? And the void is infinite. So it follows from that atoms have been falling for eternity and will continue to fall for eternity. Yeah. Everything is atoms falling through the void for eternity, right? Kind of like rain or something, I guess. Yeah. That raises this other problem, though, is how these atoms collide, right? Because the objects and events that we experience in the world on this hypothesis or on this theory are actually collisions of atoms, right? But things fall in a straight line. So if the atoms were falling, it seems like they would just be falling in parallel lines and they would never collide with each other, right? So what explains their collision? And so think about it that way. Imagine if the atoms are all falling and they don't collide because they sort of fall in parallel straight lines, it seems as if the result would be that nothing would ever change because the atoms would always be falling in the same, sort of formation, and everything, it appears to us would appear to remain the same even though it's all falling, right? Sort of in formation. But there needs to be some explanation for the change of the formation, because unless there's a change in the formation of the atoms, right? A change in their position with relation to each other, then nothing that we experience, right, or observe would appear to change. So we still have to explain the collision of the atoms, right? There must be something that makes them fall in different ways from each other or move in different directions from each other, because falling is all in the same direction. Yeah. So there's a number of possible ways this could be answered. One could say that they fall at different speeds, right? So that some of them catch up to others and crash into them, right? But that can't be because all the atoms fall through the void at the same speed. Well, why would the atomists think that all the atoms fall through the void at the same speed? The reason is they think that heavy objects fall faster than light objects. I mean, if I drop a stone or if I drop a feather, the stone will hit the ground faster than the feather does. And it seems to be that the reason is that the heavier objects like the stone push the air out of the way faster than the feather does, right? I mean, obviously the stone is going to be a denser mass of atoms and the feather is a less dense or more rare, right? Rarefied clump of atoms with more void space in between those atoms, right? So the air, though, remember, is atoms too. So we're really talking about some atoms pushing other atoms out of the way anyway when they fall through space, right? So this means that we already have different speeds in the falling of the atoms, because obviously the air atoms must be falling more slowly than the atoms of the objects that are falling in relation to the air and pushing air out of the way. But the void is empty, right? So there's really nothing to push out of the way in terms of everything falling, right? And so that means that the explanation of why some things are falling faster than others, because obviously air, since it's atoms, is also falling on this theory, and air just must be falling more slowly than the other objects that have to push air out of the way when they're on their way, right? So, right, we still have the same problem. We need to know why some things are falling at different speeds from others, right? In the void, there's nothing to make some objects fall slower than others, and so should follow that all the objects fall through the void at the same speed. Yeah. So this leads to the hypothesis of the swerve, right? I mean, obviously, there's got to be a swerve somewhere. So the idea here was that all the atoms are falling through the void, and all it takes is one swerve. One atom, just one atom can divert from its straight down trajectory and swerve and knock into one of the ones next to it, right, while it's falling, and that will make the other one, hit another one, and so we'd have kind of a chain reaction where they all start colliding into each other, right? So, the world and everything in it is a huge crash up of falling atoms because, of course, the atoms have to somehow conglomerate and, hit each other and to create the things that are made up of atoms, right? So you can imagine that. Imagine that all the atoms are falling through the void for eternity in a straight line, right? In order to actually have a world rather than just a bunch of atoms falling, they have to crash into each other, which means that you need a swerve somewhere along the line. So somewhere along the line, a swerve happened, the atoms crashed into each other, and there was a chain reaction resulting in the universe that we experience and the changing things that we see around us, right? But the question arises then, why does this atom swerve, right? And also the question arises, when does it swerve? Obviously, because the atoms have been falling through the void for eternity, so one might ask, when did this swerve happen? Why did it happen when it did? Why did it happen at all, right? And in the end, there's no reason. I mean, they say it just happened, and that was the explanation for everything else. And that still seems to be a big problem because it doesn't explain how things come to be, right? We're being told that everything is atoms in the void, right? And we're finding that, well, we can't really explain everything as atoms in the void because we have to explain how there appears to be things in front of us that change, and those things are changing, right? Atoms are moving in different ways so that we can have change, and so that means we have to actually add some kind of motion into the picture, not just atoms in the void. And for the same reason that Empedocles had to add, to the four elements, love and strife, because those were the explanatory factors for the changes and the mixture of those elements. And for the same reason that Anaxagoras had to add mind, or in Greek, nous, right, as the kind of force or explanatory factor to explain the motion of the seeds, right, separating from each other and mixing with each other. Now here we have to have also some kind of motion, not just that we have atoms in the void, but atoms falling in the void, and not only atoms falling in the void, but atoms crashing into each other in the void, which means we have to have a swerve, right? And so if there's just a swerve, but the swerve requires explanation, we're going to need something else. And if we don't have anything to explain the swerve, then our theory sort of fails to explain what everything is, right? There's something left out here. Mm-hmm. So we also have other kind of problems that atomism raises. One is the problem of qualia, or qualities, right? So philosophers nowadays use this term qualia to refer to really quality-ish qualities, let's say, right? Color, taste, sound, right? What things appear to be like, yeah. And atoms, according to the atomists, don't have any qualities. They just have size and shape. Well, why don't atoms have qualities? Because, in fact, atomism is a way to explain qualities, right? The qualities are the different things, right? Remember, the two problems here are the problem of permanence and change and the problem of the one and the many, right? So the atomists are essentially taking the view that there are many things, not just one, right? But in a certain way, they're really taking the view that change doesn't really occur because they are agreeing with Parmenides, right? That something can't just come to be out of nothing, right? And that's why they're using or postulating atoms in order to explain change, because atoms exist for eternity, and change, the appearance of change, right? They will explain just in terms of the different motions of atoms, right, in relation to each other. So the apple may come to be from the tree, and then after that it kind of rots away, but nothing actually ceases to exist or come to exist out of nothing, because the atoms that constituted that apple still exist. It's just that they're moving away into different formations than they had been before when they were constituting the apple, right? So they really are trying to in a sense, reductively explain qualities, right? In terms of certain limited number of things, and in this case, size and shape. Yeah. So atoms don't have qualities; they only have size and shape. Something like Anaximenes tried to do with air, right? To sort of reduce quality to quantity in some way. And everything is atoms in the void, right? And at the same time, again, remember, what is, and what is not. A thing can only be what it is and cannot be what it's not. As we learned from Parmenides. So it should follow from all that everything should have no qualities but only quantity, right? So, for instance, an apple is red and it's tasty and has a certain smell, or it's sweet, or whatever, and maybe shiny, right? These are qualities that it has. But the atoms that it's made of don't have any of those qualities. So the question is, where do these qualities of the apple come from if the apple is just a collection of atoms and the atoms don't have those qualities, right? If we were to say such a thing, we would be, it would entail that what is not is, right? It would entail that basically these qualities just come to be from nothing. Yeah, we're saying everything is atoms, right? The apple is atoms, and the apple is red, yeah, and therefore, right, the the atoms which are the red, which but the atoms aren't red. So what is, which is red, is what is not, which is an atom which is not red. You get the idea, right? Okay, so things have qualities. Not doing so well this morning. Sorry for that, but I think you get the idea. But things have these qualities, right? And so, how do they get these qualities? Well, Epicurus tried to solve this problem by postulating that qualities are properties of collections, right? So, of course, that's the idea here. Redness or sweetness or shininess of an apple are properties of the collections of atoms, but they're not properties of the atoms, right? And he distinguishes here between, right, qualities and accidents, right? Qualities are properties of collections of atoms that are caused by the accidents of atoms, right? And he distinguishes here between properties and accidents. So a property is a characteristic that some entity necessarily has. So, for example, an atom necessarily has its size and shape, right? Because if it were to actually lose some of its size or change its shape, then that being would just go into non-being, right? I mean, that means that, that pieces of it or that part of it would just simply go into non-existence. And again, right is and what is not, right? What existence can't simply disappear into non-existence or appear out of non-existence. And if a atom were to sort of change its size and shape, that's exactly what would happen, right? The change, again, that we experience in the world is supposed to be explained as an appearance, right? That is, at bottom, just a sort of change in relationships between atoms, which always exist and never change, right? So that means that there's certain sort of properties that they have to have as atoms, right? An accident is a characteristic that some entity happens to have, but which it can be without, right? So, by contrast with size and shape, which is a property of an atom, right? The atom necessarily has to have its size and shape and can never change. The relationship between one atom and another can change, right? They're falling through the void and they're bumping into each other here and there, so they're scattering and they're collecting in different places, and constantly their location in relation to one another is changing. So that is an accident, right? That can change. And so what he's saying here, right, is that the qualities or properties of collections of atoms, right, that are caused by the accidents of atoms, right? So redness, for example, is a quality of an apple, right? But it's a quality of a collection of atoms, because the apple is a collection of atoms, right? And so redness is not a property of the atom, it's only a property of the collection, right? But that property of redness is caused by the accidents of those atoms, the location of one atom, right, in relation to another. So is that clear to everyone? That explanation? Epicurus solution here. Okay. So, yeah, that's the explanation that I just gave, right? Qualia are not properties of atoms, but they are properties or accidents of collections of atoms. A collection of atoms is the result of many atoms' location being close to each other or close together at a given time. Location is a property of each atom, so the qualities are the results of the locations of atoms. Okay, clear enough? Good. All right, so now this explanation raises some questions by itself, though, right? It doesn't appear to actually answer the question, why do collections of atoms have qualities, right? One way to get at this problem is to ask where the qualities are. Yeah, because the atoms are out there in the void, right? So we have to ask the question, where are the qualities? Are they also out in the void? And if they are out in the void, is the quality redness, is it in the same place as the atoms, or is it in a different place from the atom, right? If the quality of redness, which is in the apple, which is supposedly just a collection of atoms, nothing more than a collection of atoms, is in the same place as the atoms, then that would be a problem, because the atoms are already in that space, and atoms don't have qualia, right? The redness, the atom is not red. The redness is not in the atom. So how can the redness be in the same place as the atom is? And if the redness is not in the same place as the atom is, then where is it? Right? Because the only thing there are is the collections of atoms. What sense would it make to say that the redness is the actual color of the apple, right? If the redness is in a different place from the apple, because if the apple is nothing but atoms in the void, then the apple must be in the same place that the atoms are, because the apple just is the atoms. If the redness is not the redness of the atoms, and therefore in a different place from those atoms, then that means the redness is in a different place from the apple, right? So how can that redness be the color of the apple or the quality of the apple? Secondly, qualities would have their own place in the void, right? And that the theory is that there are only atoms in the void, right? So it seems like we would be violating now our our hypothesis. I mean, this would falsify what the atomists are saying, claiming to explain everything in terms of atoms in the void, because there would be this other thing, qualities, which are in a different place from the atoms, and therefore must be something distinct from and over and above the atoms. We would be saying there's atoms and qualities in the void. But if they say there's atoms and qualities in the void, then there's no point. They haven't really explained anything, because what they want to explain are the qualities. And they want to explain the changes in the qualities, right? They want to explain how something can change without violating Parmenides' rule that what is and what is not, right? How can things change without entailing that something ceases and disappears from existence or either comes into existence? So, what is equality, right? It's not an atom, it's not a collection of atoms, right? And to say that it is a property of a collection of atoms seems like it just avoids the question, right? Well, one possible explanation, which is really resonates with our modern perspective, I guess, and which was not unknown to the ancients, right, is here from Democritus. That's to say that the qualities that we're talking about are not real things, but they're only features of our experience, right? So, in other words, what's really out there are just a collection of atoms, right? Not really in any real sense is there an apple out there. An apple is some object of our experience, right? So there's atoms existing out there, and those atoms cause us to experience a kind of a sweet, let's say in this case now it's not an apple but a rose, right? We experience a red sweet rose with a nice smell, right? This is the object that we experience, but that object doesn't really exist out there in the real world, and what really just exists is a group of colliding atoms, right? Now, as we think, like color exists in the mind or the eye, but doesn't exist out there, right? The physical properties, and for the atomists, the atoms and their motion and their colliding and formation is what really exists and what causes our experience of qualities like smells and tastes and color and so forth. So, for the atomists, their explanation was like this, right? That the shape of a collision, right? So we have a collision of atoms, and the shape of this collision, let's say, the kind of collision, then, it is the motion and the number of atoms and so forth, and the trajectory of their collision, right? It's all got to be just reducible to the size, shape, and motion of the atoms. Makes a kind of a vibration, we might say, from atoms bouncing off from that collision, right? And they bounce off from that collision in a kind of formation. It sort of reflects the sort of shape or nature of the collision, so to speak. It has to be the shape of the collision, right? Because again, it has to be reducible to the size, shape, and motion of those atoms. Let's say, imagine a rose-shaped formation of atoms flying off a rose-shaped collision of atoms, right? And these formations of atoms that are flying off enter our sense organs, right? Eyes, ears, nose, and so forth, our brains, which are also just collisions of atoms, because importantly, we are just collisions of atoms also, right? And when these formations of atoms collide with the atoms that are our sense organs, they cause, vibrations in them that produce our experience of the qualities of those objects, right? So we can say, right, that that qualities aren't really out there in the rose, the qualities of the rose, because that's really what all that exists are atoms colliding. Those atoms collide with the atoms that are, our sense organs, and that produces the experience, right? I suppose the experience is a kind of a collision of atoms, which is the experience of the so-called rose, because it's a collision of atoms that is a result of that collision of atoms, right? And anyway, the idea is to try to say that qualities are not real things out there, but they're just the effect of the motion of atoms on our experience, right? The problem, of course, is that our experience also has to be just atoms colliding in the void, because the theory is that, right, everything is just atoms colliding in the void. If they were now to say that there's a such thing as a mind which has experience, and then say that the qualities are just experience, well, then they're saying that there's something other than just atoms colliding in the void. There are minds that have experience, and that's, unless we say that those are also collisions of atoms in the void, which has to be the case on the theory that everything is just atoms colliding in the void, then, right, it doesn't seem like we get anywhere, because this experience that we are saying these qualities are is also just atoms colliding in the void. So we still don't really have an explanation of, right, these qualities. Yeah. So those are already getting into some of the problems that we have with this theory. Yeah. He says qualities are not real, but only features of our experience. And one way to articulate that problem that I just sort of alluded to here is, who are we in the first place, right? On this theory, there are only atoms in the void, and so it follows from that also, again, we are just groups of atoms colliding in the void. And now we're saying that one group of atoms colliding into another makes the second group, that's to say us, experience qualities. So instead of needing to explain how a group of atoms can have qualities, because atoms don't have qualities, right? And what qualities are, we also now have to explain how groups of atoms can have experience and what experience is. But according to the theory, experience has to be nothing other than atoms colliding in the void, which have no qualities, and so far the question remains, right, unanswered. And this leads us to also consider thoughts in the mind, right? Because according to atomism, again, because it says everything is atoms, the mind is just another arrangement of atoms, and so thoughts are just movements of atoms. When I think about all these things, what must be going on is some kind of motion of atoms, right, in some way or another. For atomism, thinking has to be explained in the same way that experience is explained, and so that's exactly what they tried to do. Right? So remember, with the case of experience, the idea was when you see the flower or a rose, right? Atoms coming off of it bounce into the atoms that make up your eyes, right? So likewise, when you think about a flower, it has to be for them that somehow smaller atoms or something like that come off of the flower, and they're directly bouncing into the atoms that make up your mind, right? So let's say the idea might be that the atoms that are your body, right, are kind of like larger, and there's sort of spaces in between them. So only the atoms which can, are small enough to get through the eyes, right, or get through the body into the inside of the body where maybe the mind is, are the ones that can bounce into the inside of your mind and so make thoughts. Whereas the larger atoms that can only get through between the atoms that make up your eyes, those larger atoms are the ones that sort of are the sight of the atom, or the flower, right? The experience of the so-called flower, right? Yeah, which is actually itself just a clump of or a collision of atoms outside there that's like sending atoms flying into your face, I guess, right? So there we go, right? That's so thinking is atoms as well. Thinking must be like that, according to the atomists. So this gives us a lot to think about, right? A lot of atoms to think about, a lot of atoms to stir around in there. One of the things that we can ask is that, what about logic, right? Thought seems to follow logical chains. So, for example, and this is classic Aristotelian logic, right? If all humans are mortal and all Greeks are humans, then it follows by logic that all Greeks are mortal, right? And thinking about it, we realize that 3 follows from 1 and 2, right? And we think that that's something about, reality, right? If 1 and 2 are true, 3 must also be true. Um, but it doesn't seem to be like that can be the case for the atomists, right? Because that's only how it appears to be. In reality, everything is atoms. So the thought that all humans are mortal must be some collision of atoms or some kind of formation of atoms in motion. And the thought that all Greeks are humans must be another collision of atoms. And so we have to explain that somehow when this group of atoms collides with the other group of atoms in the sort of right way, we get another group of atoms flying out, which is the idea that all Greeks are mortal, because all ideas have to be also collisions of atoms in motion, right? Yeah, so all our thoughts have to be just atoms bouncing into each other in our minds. And I mean, all I can do is ask whether you think that sounds right. Yeah. Um, we seem to agree that we seem free, I'm sorry, to think about what we want to think about. And when we think about something or we decide to think about something, it comes to mind, right? But if thoughts are just small arrangements of atoms bouncing into our minds, that doesn't seem possible, right? Yeah. And it makes us ask whether we're really free to think about what we want, or we just think we're free. And if we think we are free to think what we want, then what kind of arrangements of atoms is that thought, right? And what does it come off from, right? Uh, what kind of clump of atoms out there does that sort of little clump of atoms fly off from into our minds? Yeah. So there we go. That's the wraps up our kind of uh, review of the ancient Greek attempt to explain everything in terms of material particles. And I think we can ask, you know, we can discuss. You can think on your own, I suppose, and we can discuss later whether any of those problems are relevant to contemporary modern attempts to explain everything in the universe in terms of material particles moving around and colliding with each other, right?